Yes, ma'am.
Okay, fine. Okay, just a second. Okay, so on Friday we okay, so on Friday we had a discussion about like what is Hadoop, and before that we had a discussion on what is big data all about. Okay, so on Friday we just give you a brief about what Hadoop is all about. Okay, then now as we move further, okay, so we see that we have already discussed that there are two basic components of Hadoop. Okay, one is the HDFS, the other one is MapReduce. So, what these two core components are basically doing, what their functionality is. Okay, so let's see them one by one. So, first we'll be discussing about HDFS, the Hadoop Distributed File System. Okay, so this component is basically responsible for your storing of the data. Okay, so we have already seen that whenever we were talking about big data, so the first challenge which we were facing with respect to big data was that the storage of that data was becoming very difficult. Okay, that we didn't had a specific mechanism, or you can say that the mechanism which we were having previously, that was not that was not favorable for uh, uh, the once we store the data, it was not favorable in terms of processing. Okay, so we needed a mechanism that stores the data and stores in such a way that we can do the performance do the processing of that data. Okay, so in Hadoop, the component one, which is HDFS, was designed to basically deal with this problem of storing the data. Okay. Now there are concepts which are on the basis of which Hadoop was designed. Okay. So Hadoop as a solution has a storage layer called HDFS, Hadoop Distributed File System. We generally call it as HDFS. Okay. HDFS can store huge amount of data in multiple machines instead of a central server. Okay, so here what we are doing is that we are not storing the data as a whole on a single system. What we are doing is we are storing the data on multiple machines. Okay, and also that data is stored in distributed manner. Just a second. Yes. Yeah. Yes. So we are not storing the data in a single location. Okay. What we are doing is we are dividing the data and we are storing it on multiple machines across the cluster. Okay. So we know that Hadoop basically works in the form of cluster. Okay. So cluster basically a combination of multiple machines. Okay, we have multiple machines, and these machines are basically working together to basically process and to store the data such that we can we can process the data as a whole. Okay, not just a part of that data. Okay. Okay. Okay, because we don't want to miss out anything. Okay, we don't want that any part of the data should be missed out. So what we did was that we stored the data across the multiple machines. Okay, and also to attain the reliability. Basically, why reliability? Because since the data is, huge. Okay, we are dealing the data in or you can say, we are dealing the data in terms of petabytes. Okay, not just in GBs or in terabytes. Okay, we are dealing data in size of like petabytes. Okay, so data is itself expensive for us. Okay, we cannot afford to lose this much amount of data. Okay, losing this much amount of data can be, can be disastrous for any kind of an organization, whether it is retail sector or your Google itself. Okay, Google will also not afford to lose a petabyte of data. Okay, so in order to, maintain the reliability, what we do is we replicate that data. Okay, so replication basically means that we are making the copies of that data. Now the question may be that why to create copies. See, the copies are just created to basically ensure that in any case any of my machine gets down. Okay, gets down, or you can say it gets crashed. Okay, so whatever data stored here is not lost. Okay, so that's why what we are doing is we are also creating the replicas of the data. So if let's say I have 1 petabyte of data, so I'm also creating a copy of this data, not a single copy that we can decide upon, depends on the sensitivity of the data or how important that data is. Okay, so based on that, we decide that whether we want to create 2 copies of it or single copy of it or whatever. Okay, then it is designed with low cost hardwares. See, here the low cost hardwares is not like that the machines are down in configuration with respect to what our desktops or what our laptops are. No, they are they are much higher than that, but not that much higher in configuration with respect to not that it costs us fortune, right? So yes, they are low cost hardware in terms of we are not holding you say high, very much high performance. Yes, they are immediate, like upper than your
Excuse
normal
me,
laptops and desktops, but not
students are
much
waiting.
higher than that. Yes, someone is saying something.
Ma'am, some students are waiting.
Yeah, I have joined them. Yeah, in the
Thank you, ma'am.
yeah. Okay. Okay, so they are these low cost. You don't get confused that कि हमारे जो normal laptops हैं उनके जैसे होंगे या हमारे normal desktops which we use उनके जैसे होंगे. No, they are much higher than that. Okay, but यहाँ पे हम low cost we mention them because they are not very much sophisticated systems. Okay, then provides access to data across multiple clusters. Okay, so it is not like that only we have this cluster and we are sharing the data only across this. No, there is a proper communication or the data exchange between multiple clusters. Okay, so that is possible as well. It has high fault tolerance and throughput. Now fault tolerance is just because that we are replicating the data. Since we are replicating, so what, see, fault can be in this case, basically in this architecture of cluster, basically fault will be the one thing that we lose the data. Okay, or else देर इज नो अदर पॉसिबिलिटी कि कोई और फॉल्ट हो. ओके, फॉल्ट हमारे लिए वही है कि हम डेटा लूज कर रहे हैं, और डेटा लूज करने को हम कैसे उसको डील कर रहे हैं, बाय क्रिएटिंग द रेप्लिकाज. Okay, we are creating the copies. So that's why Hadoop has this ability to deal with any kind of fault tolerance. Okay, and this Hadoop HDFS, or you can say Hadoop as a whole, works on a master slave architecture. Now what this master slave architecture is, now what this master slave architecture is, see, just a second. Guys, please make sure you all join the session by 3 p.m. Okay, because if like it's already 3:15 and see we are having only 1 hour sessions daily. Okay, so if you'll be late, then will not be able to cover the whole sessions, right? So please make sure you all join by 3 p.m. sharp. Okay, make it a practice by from tomorrow, right? Okay. Yeah. So Hadoop works in master slave architecture. Now, what this master slave architecture is, basically, see, in the like Friday we had a brief, or you can say, I discussed with you a definition or Hadoop. Okay, this definition we studied. Okay, so what does that say? According to Apache, Hadoop is a framework that allows for distributed processing of large data across the cluster of computers using simple programming model. Okay, now when I told you that I'll explain you what the simple programming model is, so that simple programming model is this master slave architecture. Now, how this is simple? See, in Hadoop, what we do is, what we have designed it as, that we'll have a master. Okay, I'm using the term a master because we want a simple architecture. We don't want that we have multiple masters and we need to maintain the information among all the masters and all the slaves. Okay, so in Hadoop, what we have done is we have created a single master and we have created multiple slaves. Okay, so these are the slave nodes of your cluster, and this is your master node. Okay, and all these are slaves. So this is the simplest programming model. Now how it is simple? Because since we are having only one master, single master, now this single master is responsible for all the monitoring and everything with respect to all the sleeves. Okay. अब here if let's say there would have been multiple masters, तो क्या होता, इन slaves की जो information है वो इन दो masters के बीच में there would have been a कॉम्प्लेक्स सिनेरियो. ओके, आपको इंफॉर्मेशन हमेशा अपडेट रखना पड़ता. ठीक है, कौन सा मास्टर कौन से स्लेव्स को हैंडल करेगा, दैट यू हैव टू मेंटेन. ओके, सो मल्टीपल कॉम्प्लेक्स सिचुएशंस वुड हैव बीन क्रिएटेड. ओके, so in order to avoid that, we made sure that we follow a single master and multiple slaves architecture. Okay, so that's how this Hadoop has maintained a simple programming model. Okay, now let's understand further then how this HDFS architecture actually works. Okay, so I told you we have a master slave architecture, right? Now this master slave architecture, here the master is your name node. Okay, we call this master as name node. Okay, and the slave nodes are the data node. We call them as data nodes. Okay, so what this name node and what these data node does actually. So what happens, this name node has one job, that it should have all the information about what data is stored on which data node. Okay, कौन से slave पे क्या data stored है, ये सारा information नेम नोड या आपका जो मास्टर नोड है इसको स्टोर करके रखना है, ठीक है। नाउ दिस इंफॉर्मेशन इज कॉल्ड एज मेटा डेटा। आई होप यू आर अवेयर ऑफ मेटा डेटा। मेटा डेटा इज द information about the data, okay, or you can say data about the data. Okay, so name node basically holds the metadata. Now what's this metadata hold is, it holds that, okay, how many files are stored on which node, what block is stored on which node, okay, how many replicas we are having, okay, for any kind of file, okay, how many or you can say what is the storage space remaining on each data nodes, okay, so all this kind of informations, okay। अच्छा, ये तो हुआ नेम नोड का इंफॉर्मेशन कि नेम नोड के पास क्या इंफॉर्मेशन होगा। डेटा नोड के पास क्या चीज होती है, डेटा नोड इज रिस्पॉन्सिबल टू एक्चुअली स्टोर योर डेटा, ठीक है। तो होता क्या है, लेट्स से a client, okay, let's say myself, okay, I want to store a particular file on this cluster, ठीक है। So what I'll do, I'll submit the file to the HDFS. Now, as I've submitted the file to HDFS, this name node gets activated, and name node figures out. पहले वो एनालाइज करेगा कि हाउ मच लॉन्गर इज माई फाइल, ओके, व्हाट इज द एक्चुअल साइज ऑफ माई फाइल, ओके। सो लेट्स से इफ माई फाइल साइज इज लेट्स से 1 terabyte, okay, this is the file size of my of the file which I want to store, okay। तो 1 terabyte file, then what node will do, it will find out कि okay, this file is of this size, now it will go to the metadata, वो it will search among the metadata and figure out that what all data nodes are free, or you can say how much space is available on each data node, okay। And what it will do, uh, it will see all the metadata, and then it will send this file, this 1 TB file, to the data nodes, okay। And these data nodes, what they will do basically, and along with the sending of the file, name node will say that you need to distribute this 1 terabyte of file and store it across the cluster, store it among yourself, okay। So this name node, this file will be sent by name node to the data nodes, and data nodes, what they will do, they will divide this file, okay, this file will be divided into small blocks, small blocks, you can say chunks, okay, or whatever, तो ये छोटे छोटे ब्लॉक्स में फाइल डिवाइड होगी। अब ये जो फाइल डिवाइड हुई छोटे छोटे ब्लॉक्स में, these blocks, these individual blocks will be stored among all these data nodes, ठीक है। तो लेट्स से एक ब्लॉक ये, दूसरा ये, थर्ड वन दिस, फोर्थ, फिफ्थ एंड सिक्स, लेट्स सपोज ये फिफ्थ 5 ब्लॉक्स में डिवाइड हुई फाइल, ठीक है। अब ये फाइल स्टोर कैसे हुई, सो लेट्स से ये हमारा D1 है, डेटा नोड 1, दिस इज D2, this is D3, this is D4, and this is D5. I have 5 data nodes, okay। तो ये 5 blocks कैसे स्टोर होंगे, लेट्स से जो फर्स्ट ब्लॉक है, this gets stored here, second block, let's say second blocks get stored here, third block let's say gets stored here, fourth block let's say it gets stored here, fifth block let's say यहाँ इस वाले ब्लॉक पे साइज अवेलेबल ही नहीं है साइज, तो फिफ्थ ब्लॉक लेट्स से यहाँ स्टोर हो गया, okay, and sixth block is stored here, okay। Let's just suppose, okay, because this decision that where this block will be stored will be depending on the name node information कि कौन से data block पे कितना स्पेस अवेलेबल है, ठीक है। अच्छा, अब क्वेश्चन ये आता है कि ये जो ब्लॉक्स हैं ये किस बेसिस पे डिवाइड होंगे। ओके, लाइक कोई तो एक मैकेनिज्म होगा, ऐसे ही थोड़ी ना हम फाइल को डिवाइड कर देंगे। देयर शुड बी अ proper guidelines to divide a particular file, right? So what happens is HDFS में we since we have to divide a particular file, okay, this is the file 1 and I have to divide this file into blocks. So in HDFS what we did that, okay, since we have to divide a particular file into blocks, what we have said that, okay, each block, okay, one block is equals to 128 MB. Okay, so each block size will be equal to 128 MB. Okay, now this 128 MB size is the scenario of version Hadoop 2.0. ठीक है, Hadoop 1.0 में the scenario was 64 MB. ओके, तो व्हाट दिस इंटरप्रेट्स दैट कि अगर मेरे पास 1 TB की फाइल है तो 1 TB की फाइल अगर मैं Hadoop वर्जन 1 में पास करूंगी तो दिस विल बी डिवाइडेड इनटू 64 MB के ब्लॉक्स में, राइट? एंड इफ आई पास दिस 1 TB फाइल in Hadoop version 2, if I'm using Hadoop version 2, so the block size will be 128 MB, यानी कि 128 MB के blocks बन जाएंगे इस 1 TB फाइल के। Okay, now the math you can do, okay, कि 1 TB के कितने 128 MB की फाइल blocks बनेंगे? I hope you all can do. Yes.
Yes, ma'am.
या ओके, सो गॉट द पॉइंट कि ब्लॉक्स किस बेसिस पे हम डिवाइड कर रहे हैं। अंडरस्टूड एवरीवन?
Ma'am, but is there an order that we should follow?
प्लीज बी लाउडर।
Ma'am, is there an order that we should follow while storing the files? Like it's
No,
block?
see, the order is not defined. Okay, order will be dependent on name node. Okay, because name node has the information ki on which data node how much space is available. Okay, since it's not like that you'll be storing only one file. Okay, we'll be having thousands of 1 TB file, right? Just a second. Okay. Guys, please make sure you join the session by 3. Otherwise, I'll not be admitting anyone from tomorrow if he or she joins after 3 p.m. Okay, because we cannot have a smooth session like that. Okay, please make sure everyone. Okay, so basically the order is decided by name node because name node has the information ki on which data node how much space is available to store the size of your block. Okay, so this information is given by name node, so based on that only we store the blocks. Okay, so it's not like that we have D1, D2, D3, D4, D5. So we also want that data should be available, readily available and easily available for the processing as well. Okay, so that is also thing which we need to keep in mind, right? So that's why the file, or you can say the block sizes, increased in Hadoop version 3.0 as well. Okay, now still the size is small. Okay, with respect to 1 TB file, still the file size is small, but still that can be, you know, weird. Okay, now, okay, so this is how your HDFS architecture basically divides the file and stored it across the data nodes. Okay, and remember you have only single master. Okay, you don't have multiple masters. Okay, we'll see the scenario that what what problem we can face if we have only single master. Okay, that we will discuss later, but for now we have only single master, and we have multiple data nodes, and these data nodes basically do the storage of your files. Okay, now let's understand the functionalities much clearly. Okay, so an HDFS cluster consists of a single name node, single master, a master server that manages file system namespace and regulates access to files by client. Okay, so whatever regulation and whatever monitoring it's need to do, that is being done by the name node. Okay, it also determines the mapping of blocks on data node. So see, here all the mapping, so I told you that whatever file will be stored in the data node, or whatever blocks will be stored on the data node, that is being that is being monitored or mapped by the name node, because name node is holding the metadata basically holds the information, okay, how many data nodes are there, which data node has the space to hold the block, okay, where to place the replicas as well. Okay, one more thing, replicas. Acha, I told you here before that sorry, here कि हम यहाँ पे reliability by replicating the data over multiple hosts. Okay, we are replicating the data. Now how we are replicating it? See, 1 TB file was there, we divided that this file into 6 blocks. Okay, now what replication basically means, replication में हम क्या कर रहे हैं, what we are doing, हम इन blocks के replicas बना रहे हैं. ठीक है, now हम इन सब सारे blocks के हम इस कंप्लीट एज अ फाइल का ब्लॉक हम रेप्लिका नहीं बना रहे हैं, हम ये जो ब्लॉक्स हमने क्रिएट करे हैं, वी आर रेप्लिकेटिंग दीज ब्लॉक्स. ओके, नाउ दैट डिपेंड्स कि हम कितने रेप्लिकास बना सकते हैं. ओके, सो इन HDFS वी हैव दिस रेप्लिकेशन फैक्टर. ओके, वील डिस्कस इट मच क्लियरली लेटर. ठीक है, हम रेप्लिकेशन फैक्टर्स, एक रेप्लिकेशन फैक्टर होता है. Now this replication factor is basically the number, how many is basically a number which defines that how many times we want to replicate a particular block. Okay, replicate a particular block, mark my words, we are replicating the blocks, not the complete file. Okay, so here I have created one replica of these 6 blocks. Okay, now these replicas will also get stored across these data nodes. Okay, हम इन्हीं data nodes पे ये replicas भी store करेंगे. Now the question is that why? Okay, why we need to store these replicas on these same data nodes? Okay, why? Because see here, if we see, let's say अगर ये हमारा name node and we have 5 data nodes, so this is our cluster. Okay, so we have to have stored these blocks, these replicas here only, because जो भी processing, if client comes and he needs to do the processing of the data, that can be done on through these data nodes only. Okay, we cannot have an access to another data node which is residing on another cluster. Okay, so we need to have the replicas as well on these data nodes. Okay, now the replication or the files or the method to store the replicas, okay, that is important. Okay, since this one block I have already stored it here on D1. Okay, so what Hadoop does is it will not store the replica of one on the same data node. Okay, वो अगर हमने one block को अगर यहाँ store किया है, it will not store it on D1. It will either stored or on D2 or D3 or D4 or D5. Okay, but not on D1. Can anyone tell me why not on D1? Can anyone guess that if we are storing the actual block on D1, why we are not storing the replica on D1?
मैम
Uh,
I
if
think
the data gets lost, then
Yes, please be a bit louder. Okay, just a second, give me.
मैम अगर एक एक D1 ब्लॉक अगर क्रैश या लॉस्ट होता है तो फिर रेप्लिका भी उसके साथ ही लॉस्ट हो जाएगी, तो बैकअप नहीं रहेगा।
राइट राइट, डेफिनेटली, बिल्कुल परफेक्ट। यस, हम, क्योंकि अगर हम रेप्लिका भी हमारे डी वन पे स्टोर करेंगे और D1 ही क्रैश हो गया, तो हमने बेसिकली रेप्लिका भी लॉस्ट कर दिया और ओरिजिनल फाइल भी लॉस्ट हो गया। ओके, सो दैट्स वाई व्हाट वी डू इज कि अगर हमने ब्लॉक 1 D1 पे स्टोर किया है, तो हम उसे D1 पे छोड़ के कहीं भी स्टोर कर देंगे क्लस्टर में, D2 पे या D3 पे या D4 पे या D5 पे। ओके, सिमिलरली goes for block 2, block 3, block 4, block 5, block 6. Okay, so that's how we ensure. Okay, अब अगर जैसे block 2 मैंने D2 पे स्टोर किया है, so I will not store the replica on D2. I will store it on another data node. Okay, so that's how we basically maintain the reliability, or we maintain the fault tolerance in HDFS. Okay, so this is how we store the replicas. अच्छा, ये जो replication factor होता है, this basically we can decide. Okay, this is in our hand, that how many replicas we want to create. Okay, तो if the data is very much sensitive, so I'll create 2 or 3 replicas of it. Okay, so it all depends on the client which is using the cluster. Okay, so we'll see that ये replica factor हम कैसे इसको अपने हिसाब से change कर सकते हैं, that we'll discuss. Okay, so for now I hope you are understood that how the blocks are created and how their replicas are being stored. Clear to everyone? Any doubt?
clear, ma'am.
Okay. Okay. So name node executes the file system namespace operation like opening, closing, renaming files and directories. Okay. So name node is basically, it is all depend, it all executes the file system namespace operations. Okay, then the existence of single name node in the cluster greatly simplifies the architecture. Okay, so when we were talking that it is basically was following the simple programming model, that was because we are having a single name node or single master. Okay, so that's how we are maintaining the simplicity of the architecture. Then comes your data node. Now data node are the workhorses of a file system. Okay, so whatever files we are having, all the work is being done by the data node, be it storing the files into the blocks, be it maintaining the replicas, be it uh, any kind of modification client wants. Okay, so let's say client की request आती है read की या write की या anything else, all is being done by the data nodes on the instructions of name node. So whatever query, whatever job is being submitted by the client will come to the name node first, and then name node will direct the data nodes what to do. Okay, then they report back to the name node occasionally the list of blocks that they store externally. Okay, now also, ठीक है, ये तो हुआ कि ठीक है, वट एवर राइट फंक्शन यू राइट ऑपरेशन यू वांट, वट एवर रीड ऑपरेशन यू वांट टू डू or not. Okay, but how name node and data node are basically maintaining the connectivity. Okay, so there are two things. One is कि name node and data node are basically communicating through heartbeats. Okay, through heartbeats. Now, what happens is data nodes occasionally, or you can say not occasionally, they regularly sent the heartbeats to the name node. Now this heartbeat basically indicates that this particular data node is alive. Okay, so let's say I have a cluster. Okay, let's say make a small cluster of 3 data nodes and 1 name node. Okay, so these data nodes will continuously send the heartbeats to name node, and when name node receives the heartbeat from these data node, that indicates that this particular data node is alive. Okay, alive, or it is in good health, or it is basically available for any kind of work which name node wants to do. Okay, acha, what if the name node doesn't gets the heartbeat? Okay, let's say for this particular data node, name node doesn't gets the heartbeat. Okay, so what will happen? Name node, what it will do, it will acknowledge, okay, I have not received any heartbeat from this particular data node. It will search from its metadata that how many blocks this particular data node is holding. Okay, it will get the information, okay, for how many blocks are stored, how many replicas are stored on this data node. Okay, once it gets the information by searching through the metadata. Okay, yes,
Excuse me, ma'am.
yes,
Does this
yes.
mean that information being reported back by the data nodes to the name node will be stored in metadata?
Yes, yes, everything, like whatever information this data node is holding now, that all information will be stored in the form of metadata to the name node. Only that's how name node will have a control over these data nodes. Okay, because since name node is directing data nodes to work on to work accordingly, whether to write a file, whether to read a file, or whether to distribute, whether to create the blocks of the file. Okay, all is being directed by the name node. So name node should have the information that how many data nodes he has, the data nodes which he is holding, what is the space available, or what are how many data nodes can hold this particular file. Okay, so that information is being stored in the form of metadata. Okay, now once it get so I hope it's
Yes, ma'am.
clear. Yeah, so this once this data node is down, all the information which is stored on this data node is being searched out by the name node through the metadata. Okay, these blocks are these blocks were stored on this data node. There were 2-3 replica files or replicas were present for certain file, not only for one file, for certain file. Okay, so this information, once this name node gets, it will then what it will do, it will search for the replicas of the files which were stored on this one. ठीक है, तो let's say कि अगर इस वाले data node पे there were 2 original blocks, let's say A1 and B1. ठीक है, there were 2 files और उन 2 files का first block was stored here. Okay, and there were replicas of some other files, let's say R1 and R2. Okay, so these 4 files were there. Now what name node will do, it will see that okay, A1 जो कि ओरिजिनल ब्लॉक था, इसके रेप्लिकाज इन दोनों डेटा नोड में से कहाँ स्टोर्ड है, B1 के रेप्लिकाज इन दोनों डेटा नोड्स में से कहाँ स्टोर्ड है, ये जो रेप्लिकाज थे यहाँ पे, इनकी ओरिजिनल फाइल्स कहाँ पे स्टोर्ड है. ठीक है, now once all this information is being gathered by the name node, this information is being updated here in the metadata. ठीक है, वो metadata को अपने को update कर लेगा and it will mention कि okay, this data node is down. Now if let's say एक client request आता है इन फाइल्स को एक्सेस करने का, so it will automatically direct the direct the request to other data nodes which hold the replicas or the ओरिजिनल फाइल्स. ठीक है, वो इस डेटा नोड पे वो आने ही नहीं देगा उसे. ठीक है, सो दैट्स हाउ यू नो वी आर मेंटेनिंग द फॉल्ट टॉलरेंस हियर. ओके, क्योंकि हमारे पास डेटा अवेलेबल होगा, क्योंकि हम रेप्लिकेशन कर रहे हैं, सो इट विल नॉट इफेक्ट दैट वेदर दिस डेटा नोड इज डाउन और नॉट. ओके, सो दैट्स हाउ वी आर बेसिकली मेंटेनिंग द maintaining the fault. Okay, I hope you all understood.
Yes, ma'am.
Ma'am, if the master node, I mean this name node gets crashed or being down, then
Yes,
is
yes,
there
yes.
any procedure
Yeah, it's a valid
to recover
question.
the data?
Yes, it's a valid question, and we'll come to it. Okay, we'll come to it. Okay, since name node is there, it's a machine, it's an electronic machine, so even this can get down. Okay, so what is the
Yes,
mechanism,
ma'am.
or what is the situation, or how we'll be dealing with this such kind of scenario? Okay, so we have the solution for this as well. Okay, we'll discuss it. Okay, we'll discuss the scenario as well. Okay, so let's just move one by one again. Okay,
Okay.
I'll be discussing it. Okay, so the data node also performs block creation. I told you this block creation is being done by data nodes only, but the direction is given by the name node. Deletion, if you want to delete certain file or replica. Replication upon the instruction of the name node. So all whatever work this data node is doing on the instructions of the name node. Okay, since name node is our master. Okay, now let's understand key. Okay, we were talking that we have master, we have slaves. Okay, and this master is basically holding the metadata. Okay, now what basically goes, or how this metadata is being stored. Okay, and other minute things we'll be discussing here. Okay, so here if you see, we have data nodes here. Okay, we are n number of data nodes. Okay, and we have master. Now for the master, you see here we have a name node. Okay, so you have heard this name node. Okay, this is, we generally consider this as the master, but along with the name node we also have a secondary name node. Now here again mark the words clearly that this secondary name node is not a substitute of this name node. Okay, this doesn't means that अगर ये down होती है तो this is our savior. No. Okay, this is not the scenario. Okay, so here what is the job of the secondary name node? Let's understand that. Okay, so what happens is we are saying that name node holds the metadata. Now name node is having all the information which data node is holding which file. Okay, which block it is holding. Okay, now what happens is there is a limitation. Okay, now let's understand, we are not just having the clusters of, let's say, 10 machines or 50 machines. We are here talking about clusters of size thousands of machine. Okay, and if we are holding thousands of machines in a cluster, you can imagine the amount of metadata being created. Okay, and this metadata is not just is not just that the information about the blocks and its replicas, it is also holding the logs as well, which data node is performing on which file, how much updation or how much writing of a file or how much reading of the file is being done. So all the kind of logs are also being stored here. Okay, you can understand that whenever a machine, even your system, your Windows system, you are just using a paint currently, but in the background multiple operations are running, right? So उनके रेस्पेक्ट में भी लॉग आपका सिस्टम जनरेट करता है कि नहीं करता है? यस और नो?
Yes, ma'am.
Yes, ma'am.
Yes, करता है ना. Because of those logs only, you're able to recover your system sometimes if it gets crashed at certain point, right? आप बैक डेट में जाके उसको रिपेयर करते हो ना, कि आप लास्ट डेट जहाँ पे आपका सिस्टम was working fine, you basically repair your system to that date, है ना, करते हैं हम. तो that is why these logs are important. So those logs are also there in these state metadata. ठीक है. Now what happens is एक certain point के बाद these metadata are being converted in a file system. ओके, तो वो क्या करता है, इस मेटा डेटा का एक फाइल बना के वो उसको स्टोर कर देता है सेकेंडरी नेम नोड पे. ठीक है, तो सेकेंडरी नेम नोड जितने भी एडिट लॉग्स हैं इस मेटा डेटा में, जितने भी एडिट लॉग्स होंगे उनको मेंटेन करेगा, और ये जो फाइल सिस्टम इमेज है, ये जो इमेज है मेटा डेटा की, इसको अपने पास होल्ड करके रखेगा. इसका काम सिर्फ यही है, इसको एडिट लॉग्स रखने हैं और इसको फाइल सिस्टम इमेज मेंटेन करके रखना है. ओनली द जॉब ऑफ सेकेंडरी नेम नोड इज दीज टू टास्क. ओके, नो अदर टास्क. ठीक है. अब जो क्वेश्चन अभी आप लोगों ने पूछा था कि अगर मास्टर डाउन हो गया, ठीक है, मास्टर मीन्स अगर हमारा नेम नोड डाउन हो गया तब हम क्या करेंगे. ठीक है, तो हडूप वर्जन 1 था जो कि इनिशियल वर्जन था, तब हमारे पास सिर्फ एक ऑल्टरनेट था कि अगर नेम नोड डाउन है, ठीक है, लेट्स से क्रैश हो रहा है. क्रैश क्या होता है? क्रैश बेसिकली मींस लेट्स से कि आपका जो क्या कहते हैं इलेक्ट्रिसिटी डाउन हो गया, या फिर आपको कोई मेंटेनेंस वर्क करना है इस नेम नोड पे. लेट्स से यू वांट टू इंक्रीज द रैम, और यू वांट टू इंक्रीज द नेटवर्क बैंडविड्थ, और यू वांट टू इंक्रीज your storage of your name node or any kind of repairance. Okay, so यही दो सिनेरियो होंगे, इसके अलावा ऐसा कोई सिनेरियो नहीं होगा जिस केस में आपको नेम नोड डाउन होगा. ठीक है, तो अगर नेम नोड डाउन होता है तो उस केस में क्या होगा, अगर लेट्स से आपको रिपेयर मेंटेनेंस वर्क करना है तो आपको एटलीस्ट 1 or 2 आवर्स चाहिए. ओके, लेट्स से 1 or 2 आवर्स, और लेट्स से 1 डे. ठीक है, बट बेसिकली अगर रिपेयर मेंटेनेंस वर्क होता है, वी ट्राई टू कवर इट इन 1 or 2 आवर्स. ओके, कोई इलेक्ट्रिसिटी डाउन या कोई फॉल्ट वैसे है तो दैट वी आल्सो ट्राई टू ब्रिंग अप क्विकली. ओके, तो अगर इस ड्यूरेशन के बीच में अगर नेम नोड डाउन होता है, तो नेम नोड डाउन होने का मतलब है कि जो भी मेटा डेटा इस पे स्टोर था वो हमने लूज कर दिया, यानी कि वी लॉस्ट ऑल द डेटा नोड्स. ओके, तो अब यहाँ पे काम आता है हमारा सेकेंडरी नेम नोड. ठीक है, तो for 1 or 2 hours this will be down, we'll not be able to do any kind of work, but after 1 or 2 hours whenever this name node is up, what we'll do, we'll go to this secondary name node and all the edit logs and these file system images will be again uploaded here on the metadata. Okay, and we'll be able to access the data nodes again. Okay, तो ये जो फाइल सिस्टम इमेज बना, क्योंकि ये मेटा डेटा फाइल सिस्टम्स में स्टोर होगा एंड दिस इमेज इज बीइंग स्टोर्ड हियर इन द सेकेंडरी नेम नोड. ठीक है, बट इसका एक ड्रॉबैक है. ड्रॉबैक क्या होगा, ये जो 1 and 2 आवर्स के बीच में जो हमारा सिस्टम डाउन रहा है, उस बीच में तो कोई मेटा डेटा जनरेट नहीं हुआ. ठीक है, सो इन दैट केस, एंड ऑल्सो दिस फाइल सिस्टम जो हमारा इमेज क्रिएट हुआ है, दैट इज ऑल्सो नॉट अप टू डेट. नॉट अप टू डेट मतलब कि लेट्स से ये जो मेटा डेटा लेट्स से स्टार्ट करते हैं, मेटा डेटा बनना स्टार्ट हुआ 1 PM से, ठीक है। 1 PM से लेके 2 PM तक मेटा डेटा जनरेट हुआ, ठीक है। आफ्टर 2 PM ये फाइल सिस्टम इमेज फाइल क्रिएट हुई एंड दिस फाइल गेट्स स्टोर्ड हियर अराउंड 2:15 मान लेते हैं, ओके। डोंट गो बाय द एग्जैक्ट टाइम, ओके। इट्स नॉट लाइक कि सच में 15 मिनट लग रहे हैं, ओके। डोंट गो बाय दैट, ओके। आई एम जस्ट गिविंग यू एन एग्जांपल, ठीक है। सो लेट्स से कि 12:15 पे ये फाइल सिस्टम इमेज सेकेंडरी नेम नोड पे स्टोर हो गया, ठीक है। अब हुआ क्या, लेट्स से ये नेम नोड जाती है डाउन दो at 2:20. At 2:20 this name node gets down, okay. Now what happens, ये जो 5 minutes के बीच में, ये जो 2 PM से लेके 2:20 के बीच में यहाँ जो मेटा डेटा स्टोर हुआ वो यहाँ अपडेट हो ही नहीं पाया, ओके। तो जो 10 मिनट्स का डेटा है, 10 मिनट्स के जो ऑपरेशंस हुए इस बीच में, यू लॉस्ट दोज, ओके। गॉट माय पॉइंट? इज इट क्लियर टू एवरीवन? है ना? सी हियर 2 PM पे हमारा फाइल इमेज बन गया एंड दिस फाइल इज बीइंग स्टोर्ड हियर, ठीक है। और 2:20 पे माय नेम नोड गेट्स डाउन। तो ये जो 10 मिनट्स का जो बीच का टाइम था, उस बीच में जो भी अपडेशन हुआ या जो भी फाइल लोड हुई, कोई प्रोसेसिंग हुई, कोई फाइल रीड हुई, व्हाटएवर, okay, that data we have lost and this 10 minutes data can be crucial, okay. We cannot afford even losing the 10 minutes data, okay. तो हमारे पास ना लेटेस्ट इमेज नहीं होगी फाइल सिस्टम की, ठीक है। हमें मिल जाएगी, हमें मेटा डेटा अपना कुछ परसेंट मिल जाएगा, बट विल नॉट गेट द एग्जैक्ट इमेज एट ऑन द पॉइंट जहाँ पे 2:20 पे हमारा नेम नोड डाउन हुआ था। 2:20 पे जो हमारे नेम नोड की मेटा डेटा की स्टेट थी, हमें वो एग्जैक्ट स्टेट नहीं मिलेगी, ओके। सो विल लूज सम फॉर्म ऑफ द डेटा, ओके। सो दिस वाज द सिनेरियो इन हडूप वर्जन 1, ठीक है। वर्जन 2 में इस चीज को और अच्छे से हैंडल किया था, ठीक है। विल डिस्कस दैट, ओके। फर्स्ट ये रेप्लिकेशन मैंने आपको बताया कि हम रेप्लिकास कैसे स्टोर करते हैं। यू कैन सी दिस इमेज हियर कि ये log file, let's say a log file are there and blocks are created, block 1, block 2, block 3, block 4, block 5, and see how the arrangement is being done. Original block is stored here, the replicas are stored on other nodes, ठीक है। Original is stored here, replicas are stored on other blocks, other nodes, okay. So this is how the replication is happening, okay. Now by default, okay, by default the replication factor is at least 3, okay. So basically all the blocks are having 3 replicas, or you can say in total 3, basically means 1 is the original and 2 are the replicas. So in total you have 3 images of your particular file, of a particular block, okay. So if you lose the original, and by chance if you lose the first replica as well, you can always have the second, and this condition, or you can say this scenario, is the rarest one कि आप original भी lose कर दो और आप एक उसकी replica भी lose कर दो. So this is the rarest situation, okay. So that's why we say that by default it is 3. You can decide how many replicas you want. You want 4, you want 5, you want 10, you want just 2 replicas. That's up to you, okay. That depends on the data you are dealing with, okay. So this is what your block replication is heartbeats. I told you that basically the communication is through heartbeats, and if we don't get the heartbeats from particular data node, उस पे स्टोर करने वाले जितने भी ब्लॉक्स हैं या रेप्लिकाज हैं that are being figured out through the name node metadata, and if the client request comes, then those requests are being directed to the other data nodes which are holding the replicas, right? So heartbeats are clear. Okay. अच्छा, एक और चीज है that how much time we need to wait. नेम नोड कितना टाइम तक वेट करता है एक हार्ट बीट के लिए, ठीक है? सो बाय डिफॉल्ट इट इज, आई थिंक इट्स 3 मिनट्स. ओके, वो शायद 3 मिनट्स तक एक पर्टिकुलर हार्ट बीट के लिए वेट करता है. ओके, एंड अ ग्रेस पीरियड ऑफ लाइक आई थिंक ग्रेस पीरियड इज ऑफ 10 मिनट्स एज वेल. ठीक है, वो 10 मिनट्स तक so in total basically 13 minutes is the total wait time. Okay, so initially 3 minutes में वो एक हार्ट बीट रिसीव करने का वो रहता है. 3 मिनट्स में अगर नहीं रिसीव हो रहा है तो वो अदर 10 मिनट्स के लिए वेट करेगा, एंड आफ्टर 10 मिनट्स इट विल प्रोनाउंस दैट दिस पर्टिकुलर डेटा नोड इज डेड. Okay, or after that it will basically work upon कि वो metadata search out करेगा and see how many blocks or how many replicas were stored here on this data node, and it will search for the alternate storage alternate locations where it could find out the blocks or replicas. ठीक है? So this is how the Hadoop maintains the connectivity between the name node and the data node. Okay, now comes your HDFS high availability. Now what this HDFS high availability is, देखो हमने अभी डिस्कस किया था यहाँ पे कि Hadoop version 1 में we all the savior we have is only the secondary name node. Okay, and also the secondary name node is also not having the latest file system image. Okay, or you can say the latest metadata. Okay, so this cannot be a very good solution. Okay, because since we are losing some amount of information. Okay, so in order to in order to overcome the situation, okay, so in Hadoop cluster, okay, in HDFS cluster or Hadoop cluster, name node is the single point of failure. Okay, single point of failure हम यहाँ पे क्यों कह रहे हैं? क्योंकि data node का failure तो we can handle. Okay, we have a foolproof mechanism to handle the data node failure, but we didn't had the mechanism to handle the name node failure. Okay, so that's why we are calling that name node is the single point of failure prior to Hadoop version 2.0. Okay, so Hadoop version 1 तक हमारी ये प्रॉब्लम थी कि अगर name node fail होता है तो what is the solution? So in Hadoop version 2 the answer was given. The availability of HDFS cluster depends upon the availability of the name node. Okay, so if the name node is available, you can say your cluster is available. Okay, if name node is down, your cluster is gone. Okay, so now situations can be कि किस situation में आपका name node down हो सकता है. So two situations are there. If an unplanned event such as machine crash, then the cluster would remain unavailable till an operator restarts the name node. Okay, second situation can be एक प्लान मेंटेनेंस आप कर रहे हो, कोई अपग्रेडेशन ऑफ सॉफ्टवेयर या हार्डवेयर है on the name node machine which would result the cluster to be down. Only these two scenarios are there. Okay, इसके अलावा और ऐसा कोई सिनेरियो नहीं है जहाँ पे आपका नेम नोड डाउन हो सकता है. Okay, unless and until some natural disaster has happened and your complete data center is gone. Okay, so that is unrecoverable, but still only these two scenarios are there where your name node can be down. Okay, so in order to to handle this situation, what we did is in Hadoop version 2.0 we created a concept of active name node and standby name node. Okay, we created these two concepts. Okay, now what this basically means here, अब देखो, don't get confused कि active name node and standby name node we are having, so that means right now, so that means we are having two masters. Okay, no, ये situation नहीं है. ठीक है, दिस जो हमारा जो बेसिक आर्किटेक्चर है कि एक ही मास्टर होगा एंड मल्टीपल डेटा नोड्स होंगे, वी आर स्टिकिंग टू दैट mechanism. Okay, we are not deviating from that. Just what we are saying that we will have an active name node. Okay, so till when this name node is active, we'll say that we have another name node and we'll keep that as a standby. Okay, now this standby name node is an addition with that secondary name node. Okay, that doesn't means कि अगर यहाँ पे हमने active name node बना दिया और secondary name node बना दिया, सॉरी standby name node बना दिया, तो अब हमने secondary name node को हटा दिया. Okay, this doesn't means that. Okay, since we have this active name node, we will have a secondary name node. Okay, and for standby name node also we'll have a secondary name node. ठीक है, क्योंकि सेकेंडरी नेम नोड का क्या काम था, जो फाइल सिस्टम इमेज स्टोर करने का, वो हमने एज इट इज रखा है. वी हैव नॉट रिमूव्ड दैट फंक्शनैलिटी. वी वांट दैट फंक्शनैलिटी, राइट? नाउ व्हाट इज हैपनिंग, we'll have an active name node, यानी कि at a time we'll have only one master there. Okay, now all the metadata will be stored on this active name node. What will happen, we use these general nodes. Okay, now these general nodes are maintained by your Zookeeper. Okay, so Zookeeper, if you remember, in our ecosystem it was management and monitoring workhouse ka. Okay, now this Zookeeper basically maintains these general nodes, and these general nodes are basically have the duty to basically access all the metadata from this active name node. वो बिल्कुल you can say the up to date metadata will be shared with the general nodes. So as the metadata is being modified, it is being shared through the general nodes, and these general nodes share this information with the standby name node. Okay, वो standby name node से continuously active name node का metadata share करता रहेगा. Okay, now let's say if the active name node gets down and we already have our general nodes which are continuously updating the metadata with the standby node. So what will happen, this standby status will be removed and now this will be the active name node. Okay, and by that time you can repair your standby name node. Okay, जितने ड्यूरेशन के लिए ये वाला नेम नोड डाउन रहेगा, उतने टाइम जो भी मेटाडेटा स्टोर हो रहा है वो जनरल नोड से कॉन्टिन्यूसली अपडेट होता रहेगा. as it gets up, as this active name node gets gets healthy, or you can say maintained, then what will happen, all the metadata will be again shared with this active name node. Okay, so this will be standby till at that moment. Okay, so that's how the status of these active name node and standby name node gets changed as if the name node gets down. Okay, so that's how this Hadoop version 2 has handled the failure of the name node. I hope you understood.
Ma'am, so basically these both active name node and standby name node are both synced to each other.
Yes, they are synced to each other through general nodes. Basically, general nodes are basically sharing each and every state of metadata continuously. देखो सेकेंडरी नेम नोड में क्या हो रहा था, वी वर हैविंग द फाइल सिस्टम इमेज, हम वहां पे भी फाइल सिस्टम इमेज रख रहे थे, बट दैट system that image was not up to date. Okay, there is some time lag was there. Okay, 5 मिनट का, 2 मिनट का, 3 मिनट का भी हो सकता है टाइम लैग. ओके, एंड वी डोंट वांट दैट टाइम लैग. हमें चाहिए बिल्कुल लेटेस्ट, टू द सेकेंड्स हमें इमेज चाहिए. ओके, सो फॉर दैट we are basically using these general nodes to basically sync these nodes, these name nodes. Okay, so that if one gets down, we can activate the other one. Okay.
Ma'am, we saw in previous slides in Hadoop 1x architecture, the secondary name node was there, na?
Mm-hmm.
But now in Hadoop 2x architecture, is there any, matlab, I mean,
Mm-hmm.
this is standby name node is get replaced by secondary name node, or
No, no,
is
no,
there any other scenario?
no, 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 no. See, secondary name node वाला जो concept है, that is as it is. Okay, we have not removed the secondary name node. Okay, because we want these file system images. Okay, we want a particular proper edit logs which are being generated, so this we want. So be it in this active name node, this will have its own secondary name node, and standby name node will also have a secondary name node. Okay, secondary name node will be there. Okay, just what we did was that क्योंकि secondary name node was not giving us the up to date scenario, we just created two name nodes, and one we keep as active name node, and the other one we have kept as standby name node.
So these both have individual secondary name node.
Yes, yes, yes. Yes,
Okay.
yes. They will have an individual secondary name node.
Okay. Thank you, ma'am.
Yeah. Okay. So I hope this, and we call this basically what we termed it as HDFS high availability. Okay, because now what we have done is we basically have maintained the availability of the name node uh, in any situation. Okay, so that's why it is basically called as high availability feature or architecture. Okay, and this is for HDFS 2.0. Now another thing was that इससे आगे अगर आप Hadoop वर्जन 3.0 की बात करोगे तो उसमें क्या किया हमने हमने मल्टीपल, हम यहाँ पे सिर्फ दो ही रख रहे हैं ना, यहाँ पे एक स्टैंड बाय रख रहे हैं और एक एक्टिव रख रहे हैं. Hadoop 3.0 में हमने इस नंबर को, ये जो दो नंबर है, एक एक्टिव और एक स्टैंड बाय, हमने इसको इंक्रीज करके मल्टीपल कर दिया. Okay, now we have multiple standby name nodes. Okay, so kyunki why we have done that, because as the advancement of the data we are dealing with, and also the kind of processing we are basically doing, and seeing the sensitivity of the data as well. Okay, so that's why what we did was हमने Hadoop version 3 में हमने concept ला दिया कि we'll have a multiple name node. Okay, and again, though we'll have multiple name nodes, but still we'll be sticking to the concept of single master. So उसमें से let's say अगर मेरे पास 4 name node भी हैं, तो उसमें से होगी at a time एक ही active, बाकी rest of them will be the standbys. Okay, so that's why what we are doing. Okay, now देखो मल्टीपल नेम नोड्स का कॉन्सेप्ट इसलिए भी इम्पोर्टेंट हो जाता है, क्यों? क्योंकि हमारा जो क्लस्टर साइज है, वो क्लस्टर साइज हमारा बढ़ता जा रहा है, क्योंकि हम डेटा बहुत बड़ा डील कर रहे हैं. तो you can just imagine that how much, or you can say what could be the size of cluster which Google is dealing with. Okay, वो सिर्फ 1000 मशीन तक का नहीं होगा, it would be machines like lakhs में machine होंगे, उनका cluster होगा. That is how Google is able to provide you so much so much information very quickly. वो आपको इतना fast processing available करवाता है. ठीक है. So अगर आप 1000 नहीं, आप lakhs मशीन का एक क्लस्टर डील कर रहे हो, तो उन lakhs मशीन के बीच में सिर्फ 2 नेम नोड will not do anything. ओके. उस केस में तो ये 2 एक्टिव, एक स्टैंड बाय और एक एक्टिव नेम नोड will not work. We need to have multiple name nodes, right? So that's why in Hadoop version 3 we also introduced कि हम सिर्फ 2 ना लेके हम multiple name nodes रखेंगे, बस हम at a time एक ही नेम नोड को एक्टिव रखेंगे. ठीक है. Got the point? Yes, everyone.
Yes, ma'am.
Okay. अच्छा. Let's understand the how the file read and write operation basically happens. So देखो, आपका client basically submits a job to your name node, and this comes to your HDFS. Okay. Now what will happen? What this HDFS will do? It will go to the distributed file system where your file is being file needs to be stored. Okay, the storage area of the Hadoop where your file will be stored. Okay, now how this file will be stored, that it will ask the name node. वो name node से पूछेगा. ठीक है. Now name node, what name node will do, it will again search its metadata. वो metadata को search करेगा और metadata के through it will figure out that how this file can be stored. So let's say if I have a 1 TB file, okay, now it will gather the information. Now this 1 TB file, how this 1 TB can be stored? Okay, what are the data nodes which are free to store the blocks? Okay, also it will see that okay, this file is such so this is the size of the file, and it will see that okay, I need to divide it in 128 MB size if we are using Hadoop version 2, or if we are using Hadoop version 1, then it will be saying that okay, I need to divide this file into 164 MB. Okay, blocks. So this information is being gathered through the metadata. Now what this will happen, name node will give this information to your HDFS client and will pass it to your file system input data stream. Okay, now the write operation based on the information being passed by the name node, this input stream will go to your data nodes and will create the blocks of your file and store them across the data nodes, and also along with the original blocks it will also store the replicas as well. ठीक है. तो जैसे ही हमारा ओरिजिनल ब्लॉक स्टोर होता है, उसी वक्त हम रेप्लिकास भी उसके स्टोर कर देते हैं. इट्स नॉट लाइक कि हमने अभी फाइल का ओरिजिनल ब्लॉक स्टोर कर दिया एंड after 10-15 minutes or like let's say 1 hour or 2 hour or let's say next day we are particular file, name node will give you the information through its metadata कि आपको कहाँ आपकी फाइल मिलेगी actually. Okay, so this is how your write operation basically works. Similarly, read operation, ठीक है. तो read के लिए भी आपको information कहाँ से मिलेगा, आपके name node से through metadata कि आपकी फाइल थी वो कितने ब्लॉक्स में डिवाइड हुई थी, उसकी रेप्लिकास कहाँ कहाँ है. ऑल्सो लेट्स से कि अगर आपकी फाइल इस वाले डेटा नोड पे थी और ये वाली डेटा नोड क्रैश हुई भी है, तो नेम नोड आपको बताएगा कि आपकी ओरिजिनल फाइल तो क्रैश्ड है बट योर रेप्लिका इज स्टोर्ड at this particular data node, so you can access that your file here. Okay, so all the information is being received from the metadata, and the read the instruction to read a particular file is being sent to the input stream, and the input stream will take you to those data nodes only where your blocks are being stored for your file. ओके, अच्छा, अब आपने रीड करा ये फाइल, लेट्स से आपको प्रोसेस करना है. तो आपके जितने भी ब्लॉक्स होंगे वो एक साथ प्रोसेस होंगे. ओके, लेट्स से कि अगर मेरी फाइल के 3 blocks थे. Okay, and these 3 blocks were stored here, and I wanted to perform operation on the file. ओके, देखो ऑपरेशन तो ऐसे ही परफॉर्म होगा. लेट्स से कि अगर मेरी कोई एक टेक्स्ट फाइल है, तो टेक्स्ट फाइल पे अगर मुझे कोई ऑपरेशन परफॉर्म करना है, मुझे कुछ लेट्स से उसमें से कोई वर्ड सर्च करना है, तो मैं एज अ क्लाइंट आई डोंट नो कि मेरी जो फाइल है वो ब्लॉक्स में डिवाइड होके स्टोर हुई है. आई जस्ट ओनली अंडरस्टैंड कि मैंने तो HDFS में जाके स्टोर करी थी, तो माई फाइल विल बी देयर. So if I want to search a particular word in my particular file, I'll be doing on the complete file. मैं तो उसे complete file पे परफॉर्म करूंगी ना, मुझे उससे मतलब नहीं है कि वो ब्लॉक्स में डिवाइड हुई है नहीं हुई है. तो that's why when you decide to perform any operations over your file, though your file is being divided into the blocks, these all 3 blocks will be processed parallelly. Okay, and this is why we say that we basically और यही हम कॉन्सेप्ट अप्लाई करना चाहते थे हडूप में. क्यों? कि एक फाइल है, इसी फाइल को अगर मैं एक जगह यहाँ स्टोर कर देती और उस पे मैं अगर रीड ऑपरेशन या राइट ऑपरेशन या जो भी ऑपरेशन परफॉर्म करना चाह रही थी, तो अगर ये मेरी फाइल बहुत लंबी है, लेट्स से 2 MB 2 MB, आई एम गिविंग द रॉन्ग एग्जांपल, लेट्स से 2 PB की एक फाइल है, तो I will invest so much time in just processing this particular file, one chunk of file. Okay, बट क्योंकि यहाँ पे मैंने प्रोसेस को डिवाइड कर दिया ऑलरेडी, मैंने फाइल को ऑलरेडी डिवाइड कर दिया. ठीक है, अब क्योंकि ये फाइल डिवाइड हो गई, तो आई कैन पैरेलली प्रोसेस all the chunks of the file. Okay, and consolidate the result and get the final output. ठीक है, तो this is what the aim we were looking for when we wanted to deal with the big data. Okay, so this is how we are maintaining the distribution of the file and processing that file in parallel. Okay, distributedly stored and parallelly processed. Got the point?
Yes, sir.
Okay, so this is how we are speeding up the processing capabilities. Okay, so this is what your file read and write. Now if you say that when we were talking about name node, data node, secondary name node, so we call them as daemons. Okay, now name node is your master daemon, data node is your slave daemon. Okay, secondary name node, it will reside on your master node, along with your master node, and this resource manager will also reside with your master, and name node will also reside on your slave. Okay, now what this resource manager does, what this node manager does, that we will discuss eventually when we'll be moving more deeper into your Hadoop. Okay, so this is this, and see, this resource manager and node manager, these daemons are in Hadoop version 1. Hadoop version 2. I'll tell you Hadoop version 1 में क्या scenario था. Okay, so I want you all to remember कि Hadoop 2 में हमारे पास resource manager और node manager था. ठीक है, Hadoop version 1 में क्या था, that I'll tell you. ठीक है, okay, and yeah, now these are some configuration files. So when I was saying that replication factor आप change कर सकते हो, आप अपना block size भी define कर सकते हो. So those things are being set in these configuration files. Okay, now what these configuration files, देखो क्योंकि हम यहाँ पे फॉर प्रैक्टिकल पर्पसेस हम यहाँ पे क्लाउडेरा यूज करने वाले हैं. नाउ क्लाउडेरा इज बेसिकली your you can say it's a distribution of Hadoop. Okay, now when we say distribution of Hadoop, that means कि Cloudera ने क्या किया है, उसने Hadoop को ऑलरेडी आपके लिए इंस्टॉल किया हुआ है और उसके इकोसिस्टम से रिलेटेड जितनी भी चीज़ें हमने देखी थी, हमने पिक देखा था, हमने हाइव देखा था, ठीक है, वो सारी चीज़ें उसने नॉट ऑल बट कुछ चीज़ें उसने स्टोर करके रखी हुई हैं, ठीक है, और यू कैन से कॉन्फ़िगर करके रखे हुए हैं हडूप के साथ. ओके, सो क्लाउडेरा हैज़ मेड अ लाइफ ईजियर कि उसने ऑलरेडी आपको काफ़ी हद तक कॉन्फ़िगरेशन किया हुआ दिया है, ठीक है. अगर आप क्लाउडेरा नहीं यूज़ करना चाहते हो, आप चाहते हो आप खुद से क्लस्टर क्रिएट करके आप हडूप उस पे इंस्टॉल करो, सो क्या कर सकते हैं आप, हडूप जब मैनुअली इंस्टॉल करोगे तब आपको ये जो फाइल्स हैं, ये जो कॉन्फ़िगरेशन फाइल्स हैं, you have to make changes in these configuration files according to maintain the to maintain the sync between the cluster, okay, between the systems. Okay, so for that, these configuration files, so these are some four core some configuration files which are important. This core site XML is one of them. Okay, so basically it gives you the file system जो हम file system image create कर रहे थे. Here we give the location of that file system image. Okay, so this on this location, all your file system, all the metadata image will be stored at this location. Then your HDFS site XML. So here we define the replication factor. Okay, so जितना भी हमारा distributed file system के respect में हमें replication चाहिए, what we can do is we can decide the value. So here it is 1, so that means we'll have only one block. Let's say if it would have been 2, so that means the original one and the one replica. If it is 3, one original and 2 of its replicas. Okay, so this is how the interpretation goes. Then DFS permission. So if DFS permission is true, enables permission checking in HDFS. If it's false, permission checking is turned off. Okay, so if let's say for a particular file you want to see that what all permissions are allowed over those files to be carried out, so this setting you can do. Then determines where on local file system the DFS name node should store the name table, or you can say file system image. So here you can define the file system image. Then determines where on local file system distributed file system data node should store its blocks. Okay, where the blocks will be stored on the data node. Okay, so this location is there defined here. Okay, then your map reduce. So this is basically depending on your map reduce, so the other component which we were having. Okay, so all the map reduce jobs and everything that are being monitored through here, and MapReduce framework name runs the framework for executing MapReduce job. So it is basically defining कि आपको MapReduce jobs किस framework में execute करने हैं. So if you are choosing Yarn, it will be executed through Yarn, in classic or local. There are 3 options you are having. Okay. Then you have this Yarn site XML. So Yarn is basically, you can say it is the resource manager. Okay, so we'll be discussing Yarn in detail, what the functionality of Yarn is. Okay, so that is being defined here. Whatever functionality we want through Yarn, that we can define here. So these are some files which basically are important when we are basically manually installing HDFS on your cluster. Okay, so so this is all for your HDFS. Okay, So basically, till here we have basically understood that what is the work of HDFS and how files are basically being stored in through HDFS. Okay. Ab, tomorrow what we'll do is we'll see some uh, some uh, some commands which we perform on HDFS. Okay, and also I'll share with you the Cloudera image as well. Okay, so that I'll be sending you through mail. Okay, so what you can do is you can install your file your Cloudera image on your VMware. Okay, so what you do, you install VMware on your system, be it your Linux system or your Windows system. Okay, see, I'm specifically saying VMware because this VMware, because this image is compatible with VMware only. Okay, so you install VMware. If you don't have, I can share the VMware as well with you. Okay, so we'll install that. We'll install the Cloudera image, and then we'll be doing the HDFS commands. Okay, so tomorrow we'll be doing that, and then we'll be moving towards MapReduce, the second component. Okay, so whatever we have discussed today, I hope it is clear to you all.
Yes, ma'am. Ma'am, I have a doubt.
Yes.
Ma'am, regarding replication factor. Yeah, since
Mm-hmm.
petabytes of data are being stored across multiple clusters, if we increase the replication factor,
Mm-hmm.
won't it consume huge amount of data? Like it has by default, it
Yes.
has a replication factor of 3, and since petabytes of data are being stored,
Mm-hmm.
so won't it be like
Mm-hmm.
3 times that petabytes of data?
Right, right. You see, the question is
Yeah.
nice and valid. See, what we do, the issue here is, see, since we are dealing with huge amount, now you can see the scenario with respect to, again give the example of Google. Okay, so let's say Google has a petabyte of file, 2 petabytes of file. Okay, and that 2 petabyte of file is basically information being hold. Google is holding the information with respect to the people who are residing in India. Okay, so what will happen? Let's say if Google does not keep a replica of that petabyte of file. Okay, so what will happen? Let's say by chance uh, Google lose that 2 petabyte of information. Okay, so what will happen? It will lose some kind of or certain part of that information with respect to people who are living in India. Okay, so overall क्या होगा? Google will basically on Google will have the information about people here in India, but not the 100% information. Okay, हम कुछ percent data lose कर चुके होंगे. Okay, and this you we are saying क्योंकि Google के respect में 2 petabytes of data is very small, but still it is crucial. Okay, you can imagine 2 petabytes of data will be huge. कितना सारा information होगा उसमें, ठीक है? So in order, so see, the replication is being considered keeping in mind that we cannot afford to lose the data. Okay, since we are dealing with machines, we cannot rely कि हमारी machines will always be in a healthy state. Okay, so there is always chance of losing the data. So in order to basically, you know, in order to you can say, um, in order to deal with this such kind of scenario, we are basically doing the replication. Yes, the thing is valid, the point is valid that by replicating we are basically, you know, increasing the we are basically you can say, in other words, we are simply wasting the storage space. Okay, by just 3 times replicating a petabyte of data, we could have new data which can be stored. Okay, but see here, We are not just having, we are just not taking the data just for today. Okay, we want this data for a longer period of time. Okay, and since the data is important to us, so that's why we are doing the replication. Okay, see, क्योंकि डेटा को लूज करने से ज़्यादा लूज करने से ना ज़्यादा ज़्यादा इम्पोर्टेंट नहीं है कि हम उसे रेप्लिका कर लें. वी कैन मैनेज द रेप्लिकेशन, वी कैन मैनेज द क्लस्टर को हम स्केल अप कर सकते हैं, वी कैन increase the storage space. Okay, that is not expensive for us, but the expensive thing is that we lose the data. Okay, that is much more expensive for us. That's why we are replicating the data, and nothing else is there behind this decision. Okay.
Yes, ma'am.
मैम तो ये जो डेटा रेप्लिकेशन के जो मतलब नंबर्स हैं कि हम 3 बार कर रहे हैं 4 बार, तो वो डेटा के इम्पोर्टेंस पे डिपेंड करता है ना कि
Yes.
कितना इम्पोर्टेंट डेटा है उस हिसाब से.
Right. That depends on the importance of the data. That if the data is very much crucial, let's say if you are dealing with, let's say आप cyber security से respected कुछ data है आपका, ठीक है, या आप अपने let's say इंडिया की population के respect में, let's say आधार का ही data मान लीजिए, if we are dealing with आधार data, so it is a crucial data. We cannot afford to lose that. Okay. So that's why, depending on the importance of the data, depending how crucial that data is, we are deciding the replication factor. If it is not of much importance, we can afford the losing that data. We can reduce the replication factor, or we can remove the replication as well. Yes. So clear to everyone?
Yes,
Yeah.
ma'am.
Yes,
Rojitson, your doubt
Yes,
is
ma'am.
clear? You are satisfied? Okay. Okay, fine. So, okay, guys. So we'll meet tomorrow at 3. Okay, please make sure that you all join the session sharp at 3. Okay, because once we start the session, it is difficult, to keep monitoring who has joined and who is not. Okay, so that also affects the pace of the session. So I want that you all to join the sessions from tomorrow sharp at 3. Got it, everyone?
Yes, ma'am.
Okay, just a second, give me a second, please. I'm just taking a screenshot of you all for attendance. Yes. Okay. Okay, guys. So we can conclude the session for today, and we'll meet tomorrow. Okay. Bye, everyone.